So they ask you to express those numbers in standard forms.
Alright.
Yeah. So you wrote it as normal number. So it's meant to be 1 times 10 to the power of 6. That's it. You wrote 1 million. It's like you wrote it as a normal number. It's meant to be 1 times 10 to the power of 6. So in this one, 9,002 is going to be 9 times 10 to the power of 9,000. Yeah, that's going to be 4. That's going to be 3. Yeah, 3 zeros. So 40,000 4 zeros. That's it. So I know you can do it, but just I still probably misread the question. So this one was perfect. So you wrote 22 here. It's meant to be 19. I think you just missed the one there. That's the only correction there.
Yeah.
And this one was fine. There was one that I wanted to check. There was one that you did. Okay, yes, this one. There, choose 2 cards. So here, choose 2 cards that will give the smallest possible number. So you say -8 plus -8. -8. You put, what do you write here? I didn't get it. What do you write here?
Yeah, that's -8.
But there's no -8 on the card.
Yeah, smallest.
Yeah, there's no -8 on the card. So there's -4 and there's -7. So you can say -4 -7.
Yeah. Okay.
So -4 -7 will give you the smallest number. -4 -7 will give you -11. So that's the smallest number out of all of them. So choose 2 cards. I will give you 0. It's going to be -4 plus 4. That was fine. So let's choose 2 cards that will give the greatest possible value. It's going to be 6 minus -7. Yeah, fine. This one is fine.
Okay.
So let's start with this thing. So the learning outcome today is to construct graph. To construct graph, charts, and diagram. That's actually what we are going to do today. And here. So data. So the key terms today, the data. Data is fact statistics collected together for reference or analysis. So like when you want to like carry out like an experiment, or you want to carry out an analysis, you need data. For example, now to be able to predict what will happen or to assess the current situation, you need data. So the data are collected, reported, and analyzed from visualization, such as graphs, tables, or image produced. So charts is a graphical representation for data visualization, in which data is represented by symbols, such as bar charts, line charts, slices in pie charts. So charts can represent tabular numerical functions too. So when you collect those data together, you can put them in like a chart, a graph, or like in tabular form, just to compare those data together. So don't forget, I told you that data is actually what you need to you need it for analysis, to analyze current situation, or to predict what could happen. So for example, now let me give an example. Currently, the world is battling coronavirus now. So if you assess, if you collect data from the UK, okay, maybe for example now about 2,000 plus tested positive for coronavirus in the UK, and 20 people died overnight. 20 people died in the last 24 hours. 20 people died. So if you use that data compared to that of yesterday, you realize that there is increase in what people. Yes, there's increase. So if they ask you to use that one, if you compare that data again with that of the day before yesterday, you realize that this is the largest increase. So you can predict that tomorrow might be probably be higher because of the data you have on ground. Is it okay?
So yeah, found
Yeah.
static.
Yeah. So that is it. So if the data is also reducing, you can predict that tomorrow my words will reduce, will reduce better, even more better than that of actually what happened today. So data is just used to predict, to assess, again, and to actually determine, again, what can happen in the future or the current, what's happening currently. So we have type of graphs. You can watch these videos when you display type of graphs. So we have bar of what? Of pie chart. So the pie chart are represented in what? In slices. So it can be from information, for instance. So this is a pie chart. Like people, which sorry for the blurry image, but when you have this copy, you will see it properly. So you see like orange there. So in pie charts, they represent them in what? In slices. I'm going to go into more details again about pie charts. Just hold on. So the scope of coverage is what? We want to draw charts and words and diagrams derived from what? From tabular data, plot graphs, apply general rules and principles of graphical construction, then plot and interpret graphs, charts, and tables of what? Of data. So actually what we want to do. That's the scope of coverage today. So the first thing we want to do is I want to draw charts and diagrams derived from what? From tabular form. So frequency table, when there's loads of data, you try and put them in what? In like a frequency table. For example, now, Megan owns a bakery. She counts the number of customers she has each day at lunchtime. 30 consecutive days. The results are shown below. So she did this for what? For 30 consecutive days. When you say consecutive, it means that for days after the other, like those days are like they're in sequential. They're following each other. So it's the 30 days now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah. So this is what we call it. So what she now did was that you can group the frequency to be like this. The number of customers between 5 and 10, you count it. Let's count the number of customers between 5 and 10. Between 5 and 10, this one, can you see 1, 2, 3, 4. You see the 5, 6. Again, you see that there are 6 customers. Again, so that you will use this. When you count 5, you use this, what's it called? You use a line to cross it. That's the 5th line. 1, 2, 3, 4, 5, 6. You get it? So for this one too, you use this, yes, it's 14. From 11 to 15, we can go and count it. There are 14 customers there in total. Don't forget, I told you, when you are counting it, you have to say, like, when you count it up to 4, you will use line to cross it. You get it? That's the 5th one. Yes. So when you count another 5 too, you use line to cross it. That's the 5th one.
Okay.
Yeah. So just like this one now, this one is meant to be, yes, it's meant to be like that. So you can't just customize every talk the phone what you put it on the frequency. So frequency is how many numbers you find there. That's the frequency. So for example, now between 5 to 10, we found like 6. Between 11 to 15, we got 14. We're doing between 16 to 20, we got 9. And between 21 to 25, you have only 1 customer there. So you now count it. From 5 to 10, can you see 6? From 11 to 15, you see that is 14. You plot it there. So from 16 to this is what's it called? From 16 to 20, that is 9. Then from 21 to 25, that's one, I have only 1. So you put it on a graph. This is actually how the frequency looks like. That's the frequency diagram. You get it? So that is it.
Yeah, it's easy.
Yeah. So we can also represent information with using what? Using bar charts. So we still will continue with the questions that we did before. We will represent information using bar charts.
What kind of chart that was the previous one? What do you call it?
They call it the frequency diagram.
What
Frequency diagram, yeah.
Okay.
Yeah. The purpose of the frequency diagram is just like it's going to display overview of data. That's it. Just for you to plot it, just to display the overview of what of the data. That is it.
Okay, got it.
Yeah. So the other one is this bar chart. Bar chart, like frequency diagram, shows frequency of events occurring. So it's like shows you what the frequency of events occurring. So for example, now the height of the bar is the frequency. So the previous one, we know that between 5 and 10 we have 6. What's it called? We have 6 frequencies. Yeah, frequency. It counted 6 there between 5 and 10. So you put it here. Can you see? 6. Yeah. This one that is 6.
So it represents one each box, right? Each
So
line. Each line represents one, like 5, 6, 7, 8.
Yeah.
Okay.
So, for example, now this each line represents 1. Yeah, you're right. Each graph represents 1. It's meant to be like a graph, a small box there. Like 1, 2, 3, 4, 5. Yeah, a small box there. You get it? So if you put a normal graph, you get it, you realize that what's it called? That's a 6 to 1. And from 11 to 15 too, you will see that is 14. Yeah. And from 16 to this, that is going to be like 9. From 16 to 20 is 9. And from 21 to 25 is that's going to be just 1. Yeah. So the height of this, so a simple bar chart may look like this. So this is just like a simple bar chart. Don't forget that the vertical axis is always the frequency, while the horizontal is the number of customers. The vertical axis is for the frequency. The horizontal is for what? Numbers of what? Of customers.
Numbers, right.
So another one is this. We also have a different bar chart. It's called like a comparative bar chart. You get it? It's a comparative bar chart. It's different from like a simple bar chart. Okay. So, but it's the same method. You get it? So, for example, now bar chart may be needed to compare data. So, the following frequency table shows the information for the number of pets owned by a class. So, a comparative bar chart can show this information. So, a key that shows which bar represents which data is necessary to be able to read the bar chart properly. So looking at these ones now, this is like a class, data from class. Number of pets they own is the first one. So for example now, so people that have no pets, you get boys, 2 boys does not have pets, and 3 girls doesn't have pets. You get it?
Okay. Right.
Yeah. For pets, for people that have only 1 pet, 4 boys have 4 pets, and 3 girls have what? 3 pets. You get like so 1 pet, 3 girls have 1 pet. So and the data for 2 pets, 2 boys have 2 pets, and 2 girls too also have 2 pets. So people that have 3 or more, boys have 3 or more pets, while girls, only 1 girl have what? 3 or more pets. So because if it's like a normal bar chart, you just put those for example now, because it involves boys and girls, that's why we have to do comparative bar chart. If it's maybe probably it just involves pupil with number of pets, pupil with number of pets, we can use a simple bar chart. But this one, because they gave us data with boys and girls, that's why you have to use a comparative bar chart.
Okay.
Yes. So in this case, you realize that you have to you have to give what's it called? Key for boys. No, boys is represents green. White girls is what? You see red, red there. So can't it? 2 boys have no pets and 3 girls have what? No pets. Can you see now? The bar from 2 to 5 represents 3. You know that? That's actually that was 3 girls have no pets, and from 0 to 2 represent that what? 2 boys. You get 2 boys have no pets. So for the second one too, for 1 pet, you realize that what? From 0 to 4, it's like 4 boys have only 1 pet. Why 3 girls? From 4 to what? For 7, that is 3. Represents what? 2 pets. They have 2 pets. So for this other one too, you will see 2 pets. This is for 2 pets now. 2 boys have 2 pets and 2 girls have 2 pets. Why with 3 or more pets? Only three boys have 3 pets and only 1 girl. So that's actually how you have to do it. It might not be in this order. You might put it like maybe girls first or boys later, or anyone you put it. The order doesn't really matter. Is it okay? What matters is for you to represent those data correctly. Is it okay?
Right.
Any question on this?
No, so far it's okay.
Okay. So another one is called pictogram. Again, a pictogram shows frequency of events using pictures. That's why they call it pictogram. That pic is from pictures. So a key that shows what each picture is what is needed to be what? To be able to read a pictogram properly.
Okay, example?
Yeah. So example is like what? You have what? 20 people were asked about their favorite type of what? Of film. The table shows their what? Their responses.
Okay.
So for example now, for movie, genre and for the movie, horror movie, 3 people like horror movie. For action movie, 4 people like action, 7 like action. For romance, 4 like romance. Comedy, 5, and others, 1. So if you add them together, they must be 20. 3 plus 7, 10, plus 4, 14, plus 5, 19, plus 1, 20. So look at this one now. So when you see, we are using TV now to represent them. So when you see a big TV, like a full TV, that tells you that what?
4 people.
Yeah, it's 4 people. If you see action is, if you see like this is 4. If you see half, it's for 2. If you see like a 3/4, it's for 3 people. If you see like a quarter, it's for 1.
1, okay.
You get it now. It's for 1. So let's look at it now. So for horror movie, can you see how many horror movies? People 3 horror movies. So if the full one is, so that's going to be 3 people. For action, action, since 1 big represents what?
Yeah, 4.
So it's going to be 4
and
3.
And 3.
Yeah, and this one for romance is going to be what? 4. And for comedy, it's going to be this a quarter.
4 and 1. Yes.
You get it? This is like a quarter, so it's going to be like 5 and 1, and this one is going to be 1.
Yes.
That's it. So that's pictogram. Yeah. So that's pictogram. And this pie chart now. So when we do pie chart, we quickly go and let me see. I want us to do some questions. We need to do a lot of questions. I just want to explain it so we can do a lot of questions on this section, so I can be sure that you understand it. So pie charts now. I told you that pie charts are normally used what? Like you split pies. So for example, a pie chart is a chart that represents by circle. So and it shows the proportion of each group at a glance. So remember that there are 360 angles are 360. Don't forget this thing, that the sum of angle in a circle is 360. The sum of angle in a circle is 360. So those 360, you have to share it into proportions based on the data available. So, so the group, so in a circle, such as group, in a pie chart will be what? Will be proportion of 360. So a survey of the number of people traveling in a vehicle is taken. So the result is on the table now. So people traveling in a vehicle, they took a survey. One person is what? People traveling in a vehicle, one person, you get, and that gives you what?
So
That's
frequency.
You say what?
1% and white section 120. I didn't cut that point.
Okay. You know, what's it called? Like, they want to, like, what's it called? Maybe people that are traveling, maybe in a car, they took a survey of a car passing. And when they saw that car, they only saw one person there. So the number of cars that they saw one person there is, what's it called? Is 120. Just hold on a sec, please.
Sure.
Hello? So where you saw only one person, that's what? That's 120. So the car that they saw two people, the guy is what? 40. Where they saw 3 people is 13. And where they saw 4 people is what? 5. And when they saw 5 or more is 2. It's okay then, that is 2. So we want to now use that one to find out to draw the pie charts. So what you need to do is that, don't forget this frequency. So let's do the one for first person first. So, you know, I told you before, I said the sum of angle in a circle is 360. So you have to be able to divide those things into proportions. So let's do the one for one circle first, before we go to the next slide. For one person. So the first thing you do is that the formula is this. The total divided by the frequency times 360. You get it? The total is what? When you add all them together, is 180. The frequency the frequency for the first one is 120. So you multiply by 360. So the best way for you to do it is this. You will divide 360. You divide 360 by 180. What's that? 2.
2.
You now multiply 2 by 120. So what's that?
140, 240?
No. 2 is 240. Yeah, 240 becomes 2 times 120 equals to what? 240. So the angle for this one is what? Is 240. So what's the angle for 2? You will divide each time, because when you divide 360 by what? By 180, you get 2. Now do 2 times 4. 2 times 40, that gives you what? 80. So what would this one be?
It's gonna be 26.
26, yeah. What would this be?
10.
Yes. Then what would this be?
4.
4. So this is how we represent it. Can you see now you got 240, 80, 24, 10, and what? And 4. So can you see now for what this how to get this accurately? There's something they call what's it called? Do you have it? It's called protractor. That's what you use to measure angles.
Okay.
Do you get it? Now protractor is what they use. Let me see, maybe hold on a sec. Just hold on a sec. This is a protractor. That's what.
Okay.
Yeah, that's what they use to measure. I will just if you can get a math test over there, that's good, very good. A math test will have all the things.
Yeah,
So,
I do have that, but I need to. Yeah.
okay. So look at this. This is the final one. Before we start doing some questions, this is the final one. It's called a scatter graph. Do you get it? So scatter graph are good to display what? Two sets of data to see if there is a correlation. Correlation means that does those data have any relationship together? So for example, now let me give you an example of correlation. You know, in the UK, they normally sell ice cream when it's sunny. So you can say that when it gets hot, the sales of ice cream will increase because people will buy more. You know, because
Yes.
that's correlation. Because as the sales of ice cream is increasing, the number of what's it called? The sun is getting hotter. Do you get it?
Okay. Yes, the number of umbrellas.
Mm-hmm. Another one is this.
Yeah.
What's it called? Let me give you an example. The more classes you skip, the more likely you will fail your exam. You know that? Yeah, that's another thing. Yeah. Because we miss information. So that's correlation. So scatter is used to see maybe there's any correlation or connection. Connection, you can also say connection. So look at this example now. The number of umbrellas sold and the amount of rainfall on 9 days is shown in the scatter diagram. So this is the umbrella sold now. For example, now the rainfall in the first day, the umbrella sold is 1, rainfall is 3 millimeters. The next day, umbrella sold is 10, rainfall is what? 2. Umbrella sold is 23, 25, rainfall is 4, 0, 0, 1. Can you see? 1, 0, then 35, 32, 5, 47, 6, 8, 1, and this. So if you look at this one now, you realize that when the highest rainfall, can you see, at 6, that was when they showed the highest number of umbrellas. Can you see? Yes. When the highest, so the second highest is 5. So can you see now when there is 5, when the rainfall is 5 millimeters, that's when the highest umbrella sold is going to be. That's going to be 32. You get? Can you see the 4 is 25? So when there is no umbrella sold, they don't have any rainfall that day. So you can say that the number of umbrellas sold will increase depending on the rainfall.
Heavy rain.
Yes. Yeah, so that's like a correlation. There's a correlation between the umbrella sold and what? And the rainfall. Yes. So look at this type of correlation now. We also have positive and negative correlation. So when you say positive correlation, it means that one variable increases, so does the other. For example, now the one we just finished doing about the umbrella and number of rainfall is a positive correlation. Because as the number of umbrellas sold is increasing, the correlation is also what? The rainfall is also increasing.
Right.
So look at this example now. I said, as temperature increases, the number of ice cream sold also what? Increases. Look at this one too. As temperature increases, the number of coats, the jacket you wear when it's too cold, the number of jackets will decrease. That's negative correlation. So example of negative correlation is this. For example now, if you keep your food on the table, as day passes by, the quality of food will go down. You know that? Because it's going to start getting spoiled. If you leave your food without cook, without warming, so as you leave it there, it's going to get spoiled. You know, as you continue, so as day increases, it's going to get what? Spoiled. That's it. So it's a negative correlation. When something is increasing and the other is decreasing, that is a negative correlation.
All right.
So, yes. So we now try and do questions now on each type of graphs so that we can be able to analyze and pick out things there. Come in 1 second.
Okay.
So look at this one now. Then the piece of pie chart show for color of 32 colors. How many green beads are there? You know, green is like what? Like a quarter, you know?
Yes.
So a quarter of 32 is what? What's a quarter of 32?
Oh, 360, right? Oh, 32.
Yeah,
32.
yeah,
I think it's 8.
yeah, it's 8. So there's going to be what? 8 green there. So look at this one. What's the most common color in the car park? What's the most common color in the car park?
Um, Black.
Black, yeah. Thank you. What's the least common color? The least common.
Common color in parking.
Is that what?
It's blue. It is.
No, it's when you say the least common is going to be red. That is smallest.
Common.
The
Okay.
least. When you say least.
Red.
Yes. Yes. Mm-hmm. So look at this one. This is the pie chart now. The pie chart shows the information about the canters in the bag. What fraction of the canters are white?
White. I think that is third.
No, it's a quarter. White is a quarter. Can you see? It's a quarter. Did you say red? Red is a third. Why is a quarter? Yes. So look at this one now. This angle. This globe. He said, look at this one now. They said 12 is what? 12 is a quarter. You get it?
Yes,
if it's a quarter, a quarter is like 90 otherwise. So if it's a quarter, what is going to be the everything that is there? So if a quarter here is 12, if a quarter here is 12, so what's going to be everything? 12. A quarter is 12. So what's going to be the sum of everything here?
I think if it's 12. So I didn't got your question. Can you repeat again?
Is that what? If a quarter is 12,
okay.
if a quarter of a number is 12, what is that number?
What is that number?
Yeah. If a quarter of that number is 12, so what is that number? Yeah.
It's 4. It's around 4, right?
No, if a quarter, okay now, 4 quarters will make one whole. A quarter, a quarter, a quarter, and what? And a quarter. So if a quarter is 12, 12,
okay.
12, can you see 12? So what's 12 times 4?
It's going to be 48.
Yeah, that's 48. So everything is going to be 48 in total.
Okay.
So this one is like a third. So a third of 48 is going to be 16. And so you just keep on like doing it like that. So
I understand now.
Yeah. So look at this one. So look at this 7C now. So what's the most common air in 7C? What's the most common?
Brown.
Look at these bar charts.
Brown color is the most common.
Yeah. When you say the most common, that's going to be brand, because the highest. The highest of the bar is the most common.
Right.
You get it? And the highest of the bar is what? That's the most common. So how many students had black hair?
6.
Yeah, 6. Good. So how many hair color is the least popular? The least popular. When you say the least, the smallest.
Yes.
That's going to be blonde, isn't it?
Right.
Yeah. Blonde. The least. Yeah.
Yes.
So how many more students had brown than red? Add brown than red. Brown is 10.
Okay. And
red is what? 6.
4.
So it's going to be 4, yeah. So how many students are in 7C in total? So you add them all together. 5 plus 6 plus 6. 6 plus 6 is 12. 12 plus 5 is 17. 17 plus 10. 27. So there are 27 of those tests in total. So can you do this on yourself now without my help? Question 2.
I can. All right. Question 2. The most common color of a car that is red.
Yes.
Okay. How many cars were blue? And they were 12.
Yes.
Okay. How many cars were white? That will be 3.
Yes.
How many cars were red then black? Okay, so red was 17 and black is 20, so 7. So the difference will be black is 10, right? Black is 10 and red is 17.
Yes.
Red will be 7.
Yeah.
Yes. Why do you think?
No. So how many more? It's going to be take away 17 from 10, so it's going to be 7.
7, yes. The answer is 7, right? Okay. So why do you think there is a bar called utter? There is a bar called utter. Because it's different colors. That's not mentioned in the data.
So it says what?
Different colors.
Yeah.
How many cars were in the park?
So you have to add all them together.
All right.
So can you quickly do that? Quickly do it, please.
Yep, I'll interpret. 16, 10, 3, 10, and 8. So it's 49.
Yeah. So let's move on to scattered diagram now, quickly. Look at this one now. It said that what type of correlation is this? Is it negative or positive?
That is increasing, right? So
Look at it. Let me show you it. Can you see? This is positive correlation and this is negative
yes.
correlation. So what type of correlation is this now?
Negative.
Negative, yes. So what about this?
That is increasing, positive.
Positive, yeah. So it said describe the relationship. That means that what? As the test cost is increasing, time spent revising also what? Also increasing. Okay, now that's the relationship. So if we have to describe it. So another one is that if we have to draw the line of best fit, just you draw a line of best fit. You just you draw that straight line. The guy that passes through most of those values there. That's the line of best fit. Let me see, maybe I can
From
okay.
there,
Yeah. Just draw. Make sure it's straight. Make sure it's straight.
Right.
Yeah. This is also what? Positive or negative?
That is increasing, positive.
Okay. So what about this?
Negative.
So this final one, that's a pictogram. So this pictogram, you really performed well doing this pictogram. So can you do the question? Let me see, do the first question for me. Is that how many hours did James spend revising? So that James is revising for an exam. The pictogram shows how many hours he spent revising for 4 days.
So that is 4 hours.
Yes, 4 hours, yes.
Yes.
What about how many hours did James spend revising on Wednesday?
6 hours.
On Wednesday. Is it on Wednesday? You are Tuesday, yeah.
Yes, 3 hours.
3 hours, yes. So on which day did James spend 6 hours revising?
That will be Tuesday.
Tuesday. How many hours did James spend revising in total?
Okay, so we have to add 4, 6, that is 10, 11, 12, 13, 14, 15, 16, 17 hours.
Yeah. So let's do the second pictogram. So
Okay.
this is a pictogram.
That's Elaine.
Mm-hmm. Yeah,
who raised least money for charity? Kara.
Yeah, Kara, yeah. Mm-hmm.
Yeah. How much money did Ellen raise? 10, 20, 30. 30 pounds.
How much money did Diane raise? So look at this one. So if it's like Diane is like, sorry, let me just put it.
And
25. Because how much money did Diane raise? This one is 10.
Right, 10,
then 5. Yeah, it's 25. Yeah, that's it. So how much money did Elian raise than Kara? Ellen than Kara.
How much money did more? Okay, 10, 20, 30, 40, 50. 25.
No, Ellen than Kara. Ellen than Kara. Ellen than Kara. This is Kara.
All right.
This is Kara. And this is Ellie. Yeah. So you have to know how much is Ellie and how much Kara. Then not take it away. Yeah.
30 pounds.
Yeah, 30 pounds. That's fine. He said, how much money did Ellie raise than Diane?
Yeah, how much money Alice raised with Diane? Okay.
To Ellie and Diane again, you compare them together.
25.
Jan is 25. Yeah, 25. Yeah, you're right. So is that how much money did the friends raise in total?
140 pounds.
Is that what?
140 pounds.
Okay. Just hold on a sec, please. Hello?
Yeah, can you hear me?
No, I can hear you. Sorry. Just keep on getting one strange call. So
Yeah.
that is it.
140 pounds. 140.
Yeah. So let's try and do this one before we go.
Okay. So it shows the number of hours and also city for day and night. Which city had the most sunshine? That will be Clark.
Mm-hmm.
Okay. How many hours of sunshine there? So I have it's 4, 8, 8. Okay, so 9 hours.
Yes. How many? Sorry. Which city had the most sunshine? So the most sunshine. That's going to be Cork. You know?
Yeah, course. Yes.
Yeah. So how
And
many
then
hours of sunshine did Swansea have?
9 hours.
9 hours. Yes. Thank you. Yes. Yes.
More of sunshine. Yes, London. Okay. Okay, that's London. It's 4, 5, 6, 7, and Paris is uh, 1 hour more.
Mm-hmm.
So 8, 9, 10, 10. So it's gonna be 3 hours more.
Yeah. Yeah. So what will be sunshine in Paris than in London? In Paris and not London. So in Paris, that is going to be 442. That is
10.
10.
Yes,
Then in London, it's going to
7
be
hours.
yeah,
So
that's
3 hours.
3 hours. Yeah. So how do you feel today? Is it okay?
Yes, everything was good, great.
Yeah, great. So I will send this thing to you.
Sure, and I will send you my assignment, the one you give me. Yes,
Okay.
so
Okay.
hopefully by 1 hour I'll send.
All right. All right. So bye.
Bye, take
Bye.
care. Have a
Bye.
nice
Yeah.
day.
Bye. Yeah.